Students, good morning, good evening and good night. Depending on which time you are going to observe this lecture, welcome to the 5th lecture on this alcohol, phenol and ether chapter. In this chapter, in this lecture, we are going to discuss the two very important things. First, we will discuss that is the identification of the alcohol. Suppose one sample has been given to you and you have to identify whether this alcohol is primary alcohol or secondary alcohol or tertiary alcohol. At that time, what we will do, that we will discuss in this lecture. And second thing we will going to discuss, that is the preparation of the phenols. So, heading of this today's lecture is two very important things that we are going to discuss. That is, first we are going to discuss the identification of the alcohols, whether this alcohol is primary alcohol, secondary or tertiary alcohol. Second, that we are going to discuss the preparation of phenol. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. First, we are going to discuss the identification of alcohol. There are basically different tests by which we can able to identify whether this alcohol is primary alcohol or secondary alcohol or tertiary alcohol. The first test that we are going to discuss, that is the Victor-Meyer test. So first we will discuss Victor-Meyer test. In this Victor-Meyer test, what we will do, we have to react this alcohol with, first we will react it with the phosphorus and iodine. It will produce the iodide, alkyl iodide. Then it will be react with the AgNO2. Then we will going to react with the nitrous acid, and after that we will react with the NOH, and it will give a different type of colorations. So for the primary alcohol, this Victor-Meyer test is like this. Let us understand. So we write this primary alcohol. Primary alcohol. For primary alcohol, we know the formula is general formula we are talking about, that is this. After this, we have to react with its phosphorus and iodine, and it will going to prepare CH2I. After that, we are going to react with this AgNO2, and it will going to form alkyl nitrate, and after that this has been react with the AgNO2. Here what is going to happen? There is a elimination of one molecule of H2O, and this will be like this: double bond NOH and NO2. This is called the nitric acid. This is called the nitric acid. Nitric acid. And this nitric acid, when this has been react with NaOH, it will form a salt, and the color of the salt is blood red salt. Blood red coloration we will find, and from this we can able to identify this is alcohol is primary alcohol. In case of secondary alcohol, the reaction will be same. Secondary, we know this is the formula of the secondary alcohol. After this, phosphorus plus iodine, it is going to prepare this Then we have to react with H2 and it will again going to prepare like R2CHNO2, then nitrous acid, HO, nitrous acid, and it is going to form this NO and this is NO2. This is pseudo-nitrile, and when this pseudo-nitrile react with the NOH, this is going to create a blue coloration. Blue coloration. This is the blue coloration. For this you can observe. So when in the Victormia test we will find this is a blood red coloration. We form these reactions after undergoing this reaction. So you will say that is a primary alcohol. If this is the blue coloration, this will be the secondary alcohol. And for tertiary alcohol, there will be no such color change. For tertiary alcohol, when we react this in the same fashion, no change in the color. So from the Victormia test, we will able to understand identify about the alcohols. If it is the blood red coloration and the time we will find, we will say this is a primary alcohol. If it is a secondary alcohol, then it will be blue coloration, and in case of tertiary alcohol, there is no such colorations. Okay. Now we are going to discuss another test. This is called the Lucas test. Lucas test. In the Lucas test, we have to understand about a reagent. It is called the Lucas reagent. Lucas reagent is basically the mixture of concentrated HCl plus anhydrous ZnCl2. Concentrated HCl and anhydrous ZnCl2. And again, this Lucas reagent, you will find there is a different type of response from the different types of the alcohols. So when we put Lucas reagent in the primary alcohol, there will be no change at the room temperature. At the room temperature, there will be no reaction with this solution. So you can write primary alcohol with concentrated HCl plus anhydrous ZnCl2. It will do not have any reaction, no reaction. So we will not see any change in the color of the alcohol. So primary alcohol do not respond to the Lucas reagent. But for the secondary alcohol, when we put this Lucas reagent, that is concentrated HCl and anhydrous ZnCl2, at that time there will be the formation of the alkyl chloride, and this alkyl chloride will be formed. It will take some time. After 5 minutes it will form. It will take some time, and when this is formed, we will find there is a change. White coloration we find, white milky coloration in the solution. White milky coloration we can found in the solution, and white milky coloration we find, and from this we can able to understand that it is the secondary alcohol. And for the tertiary alcohol, as soon as we put this concentrated Lucas reagent, concentrated HCl plus ZnCl2 anhydrous ZnCl2. What will find? Immediately it will going to produce this chloride, and the solution, there is a change in the solution, and we will find there is a white milky coloration that we will be able to understand with instantaneous effect. So when Lucas reagent, put the Lucas reagent, and we will find there is an instantaneous change in the color. Color is become milky white, cloudy, coloration in the solution. So we will say this is a tertiary alcohol. For primary alcohol at the room temperature, it will not react. Anything will going to form there. And for the secondary alcohol, what we find? We will find that there will be the change in the coloration, but it takes some time. After 5 minutes we will find. So from the Lucas reagent, we are able to understand, identify the third test, that is the hot copper test. Hot copper test. In this test, we will observe it has been carried out in this fashion, that the vapors of the alcohol, whether it is primary alcohol or secondary or tertiary alcohol, has been passed through a hotted copper. Hotted copper is at the temperature of 573 Kelvin. So every alcohol will respond differently by producing different types of products. As for example, in primary alcohol, we will find that there is a aldehyde, there is a preparation of the formation of the aldehyde. In case of secondary alcohol, you will find ketone, and for the tertiary alcohol, you will find the alkyl. How this has been formed, that we are going to understand. From the point RCH2OH. When we put the hot, with the vapor of the primary alcohol, pass through the hot copper at the temperature of 573 Kelvin. 573 Kelvin. At the time, what we find, the process is dehydrogenation. These two hydrogen that we can easily show from this, we can show this hydrogen, or we can, this is this hydrogen. When these two hydrogen has been expelled, this two hydrogen is expelled, means minus H2. So what will remain? It will remain the aldehyde. So from the primary alcohol, we will find there is a formation of the aldehyde. For the secondary alcohol, that is CH2CHOH, this secondary alcohol. Now we are passing through the hot copper at the temperature of 573 Kelvin. So at this time, what is going to happen? You can easily understand, that is again CH, H, and these two hydrogen has been expelled out from this product, and it is going to produce the alcohol, ketone. It will going to produce this ketone. Okay. For the tertiary alcohol, that is CH3O3COH. This is the tertiary alcohol. In this case, what we will find? In this case, it will be, this is the dehydration reaction. One molecule of H2O has been expelled out from this product, and you will find it is the one molecule of H2O. This CH3, and from this you can write this here, CH2, one hydrogen is here, and this OH, we can write this way, this OH. So these two has been expelled out. So at this moment you will find that what will be there? There is the formation of the double bond. There is a formation of double bond. Here double bond is formed. So it will form, that is the 2-methyl propene. So from this hot copper test we can able to see that different type of products has been produced, by which we can able to identify the alcohols, different type of alcohols, that is the 1 degree, 2 degree or 3 degree alcohols. So there is a 3 ways by which we can able to identify the alcohols, by the Victor-Meyer test, then Lucas test, and then hot copper test. Now we are going to discuss, that is the second part of this lecture, that is how we can able to prepare the phenols from different resources. Thus, the preparation of the phenol. Preparation of phenol. Phenol is also called carbolic acid, and it has been synthesized from the coal tars. Nowadays we can able to synthesize phenol from different resources, that is the derivatives of the benzene derivatives. As for example, first from chlorobenzene. When chlorobenzene has been fused in NaOH at a very specific temperature, so we can write this is chlorobenzene. When it is with reaction with NaOH, and this reaction condition is this 340 atmospheric pressure and 623 Kelvin temperature. At this temperature it will first produce the sodium phenoxide. It will first produce the sodium phenoxide, and when this is hydrolyzed in presence of H plus ions, and it will going to create CCOH, OH, and this will give another NaCl. So this is the first, that from the chlorobenzene, this is sodium phenoxide. Sodium phenoxide. So you will get the phenol. Second procedure, that is from benzene sulfonic acid. Benzene sulfonic acid. Benzene sulfonic acid. In this way, first we have to convert the benzene into the benzene sulfonic acid, and this can be done by treating the benzene with oleum. Oleum is basically, what is oleum? Oleum basically when this is a solution of sulfur trioxide in the sulfuric acid. So its formula H2H2O7. So from this treatment with the oleum, we will get the benzene sulfonic acid, right? And this benzene sulfonic acid, when it is being heated with molten NaOH, it is being heated, it will going to produce again the sodium phenoxide, and this is again hydrolyzed in the same way that we have seen. When it is hydrolyzed, and it will produce this phenol. This is the second way that we can able to have the phenols. Number third, from benzene diazonium salt. Benzene diazonium salt. Benzene diazonium salt has been prepared from the primary amine, that is called also aniline. In this case, you will find when aniline is prepared NaNO2 and it is a very low temperature, 273 to 278 D temperature, you will find this salt, benzene diazonium salt. And this benzene diazonium salt, when it is at the warm water, it will going to produce the phenol. Okay. Fourth way that we can have from hydrocarbons. From hydrocarbon, that is cumin. From hydrocarbon, cumin is basically isopropyl benzene. So this is, you can write C6H5CH CH3 equal to, this is benzene isopropyl, and when this has been oxidized, it will going to produce the cumin hydroperoxide. Cumin hydroperoxide is this CH3, 2 CH3 will be there, and here you will find it has been oxidized to this cumin hydroperoxide, and this is when being hydrolyzed in presence of H plus, it will going to produce the phenol C6H5OH plus, you will find it will going to produce the acetone. Okay. Fifth way, that is decarboxylation of salicylic acid. Decarboxylation of salicylic acid. In this case, that this is the salicylic acid. When it is with CaO, soda lime and NaOH, so it will going to produce the sodium phenoxide will be prepared, and after that when we hydrolyzed it, it will going to produce the this is CaO and NaOH, CaO soda lime, and we have given the NaOH, and here it will be decarbonized and it will going to produce the sodium phenoxide, and from the sodium phenoxide we will get this C6H5MgBr. When it is been oxidized, it will going to produce this C6H5MgOBr. And when this is hydrolyzed in presence of acid, it is going to produce the alcohol, and with this it will going to produce MgOH Br. So this is the sixth way that we have discussed, that is from the Grignard reagent. So in this lecture we have discussed, first we have discussed about the identification of the different type of alcohols, We have discussed the Victor-Meyer test, then Lucas test, and we have hot copper test that we have discussed, how we can able to identify it. And the second part of this lecture was the phenol. How do we are able to produce the phenols from different derivatives of the benzenes. That is from the chlorobenzene, from the benzene sulfonic acid, from the benzene diazonium chloride, from the cumin, from the decarboxylation of the salicylic acid, and lastly that we have discussed, that is the ignite reaction. So that is all for this today's lecture. In the next lecture we are going to discuss about the chemical and physical properties of the phenol. That is all. Hope all the points are clear to you. If you have any doubts, you can write in the comment sections. Thank you very much for watching.